The next challenge was simplefileserver. This was a fun challenge. We strung together 2 bugs. The first bug is a unzip bug where you can use symbolic links, and the second bug was brute forcing the Flask session token. So it's web simple file server. All I wanted was a website letting me host anonymous files anonymously for free forever. We're given a link. This takes us to the website, and we're given a download file. Looking at the downloads, we're given a Docker file, so we can see it's a KCTF Docker. There's going to be SQLite. There's a flag file, flag binary, and a flag file. The flag file is going to be set to root only, and then there's this flag program with a setuid bit. So we have to call this flag program, so we can't just read it off disk. We specifically have to get execution. And then it's going to do some stuff. Make dir uploads, SQLite. It's going to create a table called users, and there's username, password, and then this admin boolean, gunicorn, bind, config file, and some logging file. It looks like the logging file will be here. Cool. Here's the rest of what we get. So there was that flag file, and it looks like all it does is the flag binary. It looks like all it does is just reads the flag file. So like I said, we have to get execution. And there's the WSGI file, nothing too exciting. And then we have an app.py and a config.py. So in the config.py, it's going to set the secret key used for sessions. And this is a little strange. So it tells us that there's a secret offset and it's redacted. And it's going to seed random based off of the time and this offset. And then the Flask secret key is just going to be some hex from the randints. So if we could figure out the secret offset and we know roughly the time, we should be able to brute force the secret key. So something to keep in mind, and that's used for Flask sessions. If we look at the app.py file, there's some temp directory, content length for uploads, a bunch of logging. There's that secret key. There's a login handler, username, password. It's going to do SQLite. It doesn't look like a database injection. Check password. And if we log in, we'll get the username, and it's going to set something called admin. I feel like this should be isadmin. It's a Boolean flag. Then there's register. We can create a new user, username, password. The database.db is in the temp directory, which is interesting. The username is already registered, blah, blah, blah. And when we register, admin will be false. Okay. Then we have a upload route. It'll make sure we're logged in. It'll make sure it's not a GET request. Check to make sure we uploaded files. If we did upload a file, it's going to generate a UUID v4. Going to generate a path for it, save it there. And this is where another bug is. So it's going to do subprocess.call unzip. What's fun about this is we can actually zip in symbolic links. So we should be able to read elsewhere on disk. And we'll check that out in a bit. And it says user, blah, blah, uploaded a file. This is how we read. Send from directory. So you can't do directory traversal. So we can read anything in the uploads directory. And then there's a flag route. So if session is an admin, it'll run that flag setuid binary, and we'll get back the flag. So it looks like the goal of this challenge is somehow to get that isadmin session variable to be true. And if we can do that, we get the flag. So there were 2 steps to breaking this app. The first one was the zip bug that I mentioned. So using unzip, you can upload symbolic links, and using those, we can read files off of disk. So to see what that looks like, this was the solve for the first part. So we can create a zip file. So we're going to create a bunch of symbolic link files. So etc password, app config, app flag, temp server log. We could also download the SQLite database, but that might be one way to log in. But I didn't see a default account created, and even if it was, the password would be hashed. So I didn't even try to download the database. But we can download these files, and so then we do zip. We allow symlinks. We create this exploit.zip, and we give it all this stuff. So if we go back to the file, so we can actually register an account, let's call it sgpit sloppy joe pirates 2 sloppy joe pirates 2. And we can upload something. So I already made one of those exploit zips. We can upload it here. This is our new file hash. And if we go, one of the symlinks we created was Etsy password. So if we ask for password, we get the Etsy password, just like that. So pretty cool. We can read any file off of disk. We can't read the flag file because the permissions were set on that, so only root could read it. But this is a pretty powerful primitive. The next step is, instead of trying to log into someone, we're actually going to try and forge Flask cookies. So if we remember the config.py, there was the secret offset and how it sets the secret key. So there's a couple steps to this exploit. Backing up, the final goal is to get it such that session.getAdmin is true. And if we look at our cookie, let's get at this cookie. I think there's a Flask session cookie decoder online somewhere. Maybe it's this one. I think you can also just do base64 decode, but we'll do this one. Cool, so we can see it says admin equals false and UID is sloppy joe pirates 2. Cool, so we need, if we can get this to be true, we'll be able to see the flag. And so like I said, we're going to try and forge session cookies. So in this config file, if we know what the secret key is that's used to generate the session cookies, we can create our own session cookies. So we don't know what the secret offset is, but we can use that symbolic link bug to read config.py off of disk from the remote server. And we can also, thankfully there was a whole bunch of logging stuff, and since there is logs, we can also get the log file and read it to see when the server started. And so if we know when the server started and we know the secret offset, we can brute force around here and figure out which one generates the key. Thankfully there's a tool that helps us do this, solve cookie. So actually backing up, so this is the script that I use to brute force and get the cookies. So first I grabbed a cookie off of the remote host. Then there's this tool called Flask Unsigned that does almost all the heavy lifting for us. So we'll do Flask Unsigned, decode cookie, make sure everything's working correctly. Then we're going to pull this off the server logs. So we had, it was, I think, server.log. It's probably going to be a big file now. Oh, it's not too bad. We can grab this. And now we know when the server started. There were a bunch of crashes in here, but nothing looked too exciting, like I searched around for the flag and stuff, but there wasn't anything there. So we use this to grab out the timestamp because we need to do time.time. This just verifies that it's roughly what we think it is. This is that secret offset. So like I said, we can grab, we did a symbolic link to config.py. And so we can see that the secret offset is here. So we have the secret offset. And from there, we're going to use Flask Unsigned to brute force the key. The way Flask Unsigned works, maybe there's like a Python API for it, but you can also just pass it a word list. So I just generated, it looks like 10,000 guesses. So I take what the server time was, I subtract 2 seconds from it, and then I go forward, what is that, 10 seconds or so? And I just brute force all of them. Time.time returns a float. So you do need to, if we do Python 3, import time.time, and it's going to multiply by 1,000. So we do need to, we'll have to brute force all of those, those values too. It's not just seconds, it's thousands of a second too. Anyways, we just, we create that giant word list. I probably have one still, yep. And it just looks like this. So this is, all of these are potential Flask keys. We'll go through the Flask Unsigned, given a word list and a cookie, it'll tell you which one is the one. Then I just ask it, I run the command and then I just read the output. Instead of parsing it, I just do a Python input, get the key, and this is what I want the new key to be. So it'll generate one with admin true, and then it'll do yeah, all of this for us. So Flask Unsigned will also forge cookies. So we say we want to sign a cookie, we'll give it our new cookie, which just says admin equals true, the secret we generated, and a word list. It did this. Let's check the server log. Let's see if it's still the same time. 2013. I think it restarted, but we can try to generate a key and see if it still works. Yeah, it did restart. 114. So 2303 32. So this is, oops, maybe we'll leave this. So 23, 1, 14, 23, 03, 32. So that'll line up at the same time. Let's get a new cookie. Oops. From here. So this is our current session cookie. We'll put that here. And anything else need to change? No, I don't think so. Where is this? Is this under exploit? Yep. So now we're going to run the script and see if it can brute force a new cookie for us. Cool. So we generated a word list based off of the secret offset and our guess of the time. Generated a giant word list. Then we sent it to Flask Unsigned to brute force the correct key. It found this key. Then we're just going to pass it back in, and it's going to generate a fake session for us. So now we have a fake session. We can go back here. We'll just update our cookie. Call that good. And we should just be able to go to flag. And there's our flag. So very fun challenge. It was fun to string together those two bugs. Cool. Thanks.